In this lecture, we are going to talk about some more important terms that we come across in the finite element analysis or finite element method, right? Now, so why do we need meshing? So if you consider each and every body in this physical universe, what will happen is they are all continuous in nature. Continuous means what will happen, each and every body will consist of infinite number of points, and for that infinite number of points we have 6 degrees of freedom for each point. So in order for us to solve the problem, see, we have infinite number of points and we have 6 degrees of freedom at each and every point. So how many number of equations are required to solve this particular problem? We need 6 into infinity, which gives you infinite number of equations. So can we solve infinite number of equations? No, I don't think so. So what we are going to do is, using FEM and meshing concept, we are going to convert this body which is having infinite number of points to a body where it consists only finite number of points, and at this finite number of points we are going to calculate whatever the results that we require, and then we are going to translate those results to whatever point we want. So these points at which we do calculations are nothing but called as the nodes, right? And the connecting elements that connect different nodes are called as elements, elements, right? Fine. Now see, we have converted these infinite points into a body which is having 8 points, or let us say 8 nodes, and at each and every node we have 6 degrees of freedom. So according to the formula, we have 8 nodes and 6 degrees per each node. So what will happen, the total number of equations to solve will be 8 into 6, which will be 48. So a computer or a human can also solve these 48 equations, so that we will be able to get the results for this continuous system. So this is why we need meshing. Now coming to the example, see here I have a round object and I want to find out the circumference of this particular object, but I don't know the formula. So what can I do? So what I will do is, I will take a simple thread, and what I will do is I will place the thread in the form of a triangle like this, and based on the length of the thread I may try to estimate the circumference of the circle. But in this case, what is happening, if I am going to put the thread in the form of a triangle, lot of area is going uncovered. It is going uncovered. So what will happen is, whatever the result I am going to get, I am going to get a error result. So for me to decrease this error, what can I do? Instead of placing the thread like this, I can place the thread like a square. Now if you are able to see, it is able to cover more area. When compared to the previous case, it is able to cover more area. But then also, if you see, if I take 4 sides also, this particular area that is being left is very large. So I will again increase the number of sides, and see here, as I am increasing the number of sides, what is happening, the area that is being left out is decreasing. So this is what is called, in technical terms, called as the mesh refinement. So if we are going to refine the mesh more and more amount of object is going to be covered properly, and the results will be more accurate. But remember, refining mesh will also increase the computation time. Then, so nodes and elements. In finite element analysis, we divide our model into small pieces. These small pieces are called finite elements, and the elements that connect all the characteristic points, these characteristic points are called nodes, and the elements are those which connect all these nodes, and they lie on the circumference. And the connection is a set of equations called as a shape function. So whatever the connection that is being created here, this will be defined mathematically, which is called as a shape function. So using these shape functions only, we will determine the value at different positions or points. We will try to determine the value of the required results at different positions. Now, each finite element has its own set of shape functions, and this will connect the nodes of that particular element. And remember, adjacent elements share a common node. So for example, let us say here there is an element, let us say element 1 and element 2. If you observe, this element and this element are sharing this node commonly. See, one this element, this and this node commonly, right? So adjacent elements will share the nodes, right? So what does it mean that elements share a common node? That means they are having somewhat similar shape function and they are being tied using this common nodes. So the shape function of this element is being tied to the shape function of this element using the presence of common nodes. Okay. Now we are going to see what are all the different types of meshing elements that are generically available. So the first type of element is called as a 1D elements, where the finite element geometric shape will be somewhat like this. We have nodes and each node is connected by a long element. So what is the geometric property this particular element is having? It is nothing but having the length. So if you define the length of this element, it itself is fine for defining the finite element in the 1D type, right? But in addition to the length, we need to provide some additional geometric data in the form of area of cross section or A to this particular 1D type of elements. Examples for this 1D type of elements are nothing but cantilever beams, beam elements, bar elements, rod elements, pipe elements. These are all different examples of 1D type of meshing elements. The next type of elements are 2D. 2D means it is having two dimensions. Instead of one dimension, it is having two dimensions. So the type of elements will be either triad 3 and triad 6 or quad 4 or quad 8. If you are able to observe, there are two types of areas. One is the triangular area and the one is the quadrilateral area. And in this also, if you see, there are nodes at the end of this particular shapes. And here, in addition to those nodes, we are having nodes at the middle of the sides also. If you observe, same thing is happening with the quad also. So these are called as linear elements. These are called as higher order elements or parabolic elements, higher order elements. Likewise, if the element is containing nodes at the end only, they are called as linear elements. But if they are containing nodes in the middle of the side also, then it can be called as a higher order element or parabolic elements. So the geometric property that this element will be having is nothing but the area. Then in addition to the area, we also need to give the thickness data through by inputting through properties for this 2D type of elements. Then coming to the third type and the last type, we are having the 3D elements, which is nothing but the volume, and this will be having a shape of tet 4 or tet 10 and hexa 8 or hexa 20. And geometric properties, it will be containing the volumes, so you don't need to give any additional data regarding the geometry for the analysis. And if you see here, the all terms are being represented like hex 20. So hex means it is the shape of the element, it is the shape, and 20 means a number of nodes. Based on the number of nodes only, we will be able to define whether it is a linear element or a parabolic element. And in addition to this 1D elements, 2D elements and 3D elements, we will be having some elements called as 0D elements, or they are also known as miscellaneous elements. So simple elements which can represent springs, concentrated mass or rigid links, all these things comes under the 0D type of meshing elements. So this is a very basic overview of different types of elements that are 1D elements, 2D elements and 3D elements and 0D elements that we use for dividing the complicated object into simple objects using the technique of finite element method. Okay.